Video 11.2, graphing piecewise functions. This is day 2 of that, and we are going to primarily deal with ones that now have parts of their functions that are not linear parts. All right. The process is the same, just now we're going to deal with things that have a little bit more involvedness, and that might not be as easy to obtain the points as it was for a linear one. So let's look at this first example here. So again, key things here is that you need to figure out the point values and the points in general for the portion of the graph that you need. So in this first one here, we're dealing with what would be the portion of the function of just x squared, and we're going from all the x values that are less than or equal to, just less than -1. So let me give a little part here. So my x's and my y's for y equals x squared. So if I plug these in, again, I'm going everything from that's less than -1. So -1, -2, -3, -4, so on and so forth, right? And we know that it's going to be open. An open circle because it's not including -1. Again, now I just plug those in. You can plug them into the calculator. You can do it in your head. If you wanted to, you could also take your calculator, plug into the y equals the function, and then don't forget you can hit second graph. That gets you the table. So the way I did it, my first column here, y1 is my first function, x squared, and y2 here is my second function, x minus 5. So if I just scroll up here, so I have -1 through -5, so I'm going to have 1, 4, 9, 16, 25. So I got all those values that are applying here. So I'm going to write those down, 1, 4, 9, 16, 25. Obviously I can keep going, but I don't even think I'm going to be able to graph 25 here on my graph paper, so that's enough. All right. And then I can do the same thing for the second function, this one here. So now I've got y is equal to x minus 5. So I want the table for that. Again, for -1, where x is greater than or equal to. So it's -1, 0, 1, 2, 3, so on and so forth. We know this is going to be closed. Sorry, it's a little sloppy there. And then again, if we go to our table, let's see, -1 gets us -6, -5, -4, -3, -2. Again, or just plug them in, which is fine. And now I'm going to graph these portions, right? All right, so let's go for here. So -1, 1, -1, 1. Again, we had an open circle for that. Be a little bit more accurate there. There we go. -2, 4. You got -3, 9, and -4, 16. That goes off of my graph paper there. So that one I cannot, not going to be able to fit that one. That's fine. That's okay. Again, notice it's a parabola, right? All right, this one's a parabola. So there has to be a curve here. So I got to make sure that while I'm doing this, doing my best to kind of give it here and my curve. Now I'm just going to go back and make my points a little bit more defined there. There we go. All right, and then for the second one, this one's linear. All right, so again, I've got -1, -6. That was a closed circle there. -5, 1, -4, 2, -3, and 3, -2. Again, I'm going to use a straight edge, so for here, I'm just going to use my drawing tool here. There we go. And again, this one has a arrow on that side. All right. Again, these are not restricted. I mean, they are restricted domains, but it's not, they're continuing on forever, in this case, to the right for this one and to the left for that one, so I got to include the arrows. All right, and that's your piecewise function now that's dealing with a non-linear portion. So the process doesn't change. You just got to make sure that the graph fits the description of it. So I can't just make this a straight line because it's a parabola. So if I was to do this whole one, it would have looked like this, right? But I don't need the pink part. I just needed the blue part. So that's all we need there. All right, let's look at example number 2. So again, one of my things that I like to do is I like to identify right off the bat what kind of functions I'm dealing with. So here I've got an absolute. So an absolute value. So if I go to graph that one, right, my x's and my y's. Now this one, they have a defined start and end. So I'm going from -4 all the way down to 2, right? It's not including those points. So this is an open circle here. And it's also opened here, okay? So again, you can go into your calculator or you can just plug them in. Absolute value here is a nice simple one. So just the absolute value is the positive version of that value. So this is 4, 3, 2, 1, 0, 1, 2. All right, and then for the second one here, we've got just 6, right? So that's a horizontal line. It is linear, but it's y equals 6, horizontal line. So for x's and y's, it says from 2 to 7. So 2, 3, 4, 5, 6, 7. So again, we're including this one. So we're closed here. And we're closed here. Again, for this one, it's a horizontal line. So for every x, y is 6. So all of these values are just 6. Again, you could plug it in the calculator. There's no need to, since obviously they're all the same. But if you did, you'd see that come up on the table as well. All right, so let's go to graph these parts now. So I got -4, 4. It's right here. Oops, again, that was an open circle. We've got -3, 3, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2, and again, that was an open circle there. All right, so if I connect those dots, I get that. And then the other portion is from 2, we got at 2, 6. So that was a closed circle there. And then we got all the way to 7. One more. Right there. I'm just going to do this one in blue since I don't have a pink one here. Oops. Make that a little bit nicer. That looks better. And there we go. That's my piecewise function. So in this case, there's no arrows at all because our defined restricted domain for each of them has a start and an end. There's no continuing on forever at any point. So this one here has no arrows at all for any parts. All right. And again, it's key to make sure that you have the correct open and closed circles for each of those things. All right, let's try 2 more. The 3 is a little different, but generally the same concept here. We've got a radical function here. So let's say y is equal to rad x. So we're going x's and y's for x is greater than or equal to 0. So 0, 1, 2, 3, 4, 5, so on and so forth. It's closed. All right, for that one. And then we're going to also say when y is equal to -3, I'm sorry, x minus 3. Right, so I'm going to find my x's and my y's for that one when x is less than 0. So 0, -1, -2, -3, so on and so forth. Once again, you can plug them in here, or you can just do it in your head or use the calculator, whichever means you want to do here. So square root of 0 is 0. Square root of 1 is 1. Square root of 2, that's a decimal. That's 1.4142. Square root of 3, also a decimal. Square root of 4 is 2. So on and so forth. Now, when dealing with these, this one here, I would recommend here, right? Radicals. I want as many points as I can to graph to get the functions, you know, kind of the trend. So obviously these decimals might be a little bit difficult. If I continued here, right? If I continued on here down to my next perfect square, which would be 9, that would be 3. So I would actually, if I could fit this, I would go about that and try to get at least one more of these solid points so that I have something easy to graph, especially for things like that one, which are like radicals that are a little bit more involved there to do from here. All right, let's plug this in. So I got -3, -4, -5, and -6. I think that's fine. We don't need to go any more than that to be able to graph that part. So let's do the radical portion. So we got a closed circle at 0, 0. And we got 1, 1. Again, 2, it's hard to graph the 1.4. You know, we know that it's, you know, just a little bit less than a half. This should be a little bit more than a half, right? 4, 2 is here. And then we know at 9, so if I can count here, 1, 2, 3, 4. Oop, I do fit it. We go 9 has to be over right here. So we can see, right, that all of this is happening. We've got that curve going on, and this does have an arrow because we're not ending at 9, we're continuing from there. And then the other portion is our linear part. So we got 0, -3. This is open, this portion. So 0, -3. Here's my open circle there. Then we got -1, -4, -2, -5. -3, -6, so on and so forth. And we can sketch that. Don't forget my arrow for that one. With those, all right? Again, now one other thing, when it comes to the linear ones, you know, you can just kind of graph like you would normally do a normal one too. I could say, well, the slope is 1, it crosses at -3. And so on and so forth. But you just got to be careful with that if you are going to do that, because it doesn't always necessarily cross the y-axis. So just be careful if you go to graph it. If it, you know, you want to make sure you're only including the points that are described in the restricted domain for those ones. All right. You can also graph it using the parent functions, you know, and you know, what type of transformation occurred to those things when dealing with them. So. All right, last but not least, we've got one more example here of actually doing this, and then I do want to talk about a transformation portion of this too. So here we've just got a regular linear function for the first one, y is equal to x, and we want that from when x is less than -2, so -2, -3, -4, -5, so on and so forth. All right, and that's going to be open circle. So if we plug those in, we've got, it's just x. So -2, -3, -4, -5. That one's not too bad. We've got the absolute value of x plus 3. So this is on the outside. So if you think of it from a transformation perspective, it's an absolute value up 3. So if I plug these in, we've got from where x is greater than -2, so -1, -2, -1, 0, 1, 2, 3, you know, however many you want to go with there for that. And let's see, that would be what? It's going to be 2 plus 3 is 5. This is going to be 4, 3, 4, 5, and 6. And this was a closed circle for that point. All right, so let's graph this one. -2, -2, open circle. -3, -3, -4, -4, -5, -5, so on and so forth. I'm going to do this one again in green since I don't have a pink line here. When you're graphing, do be diligent here and accurate as possible. All right, make sure you clearly show open circles. Right now, looking at this, I don't like how that doesn't really look like an open circle, so I'm going to go back and make that adjustment there. You want to really make sure that the key parts of this are clearly defined. So that's a closed circle. -1, got -1, 4, 3, 1, 1, 2, 5. Oops, sorry, this should have been, take that back. -1, I don't think I went high. 1, 2, 3, 4, 5. So that's 4, 3, yep, this one's here, it's 4, 2 is 5, and 3 is 6, and that continues. So I'll do this one in blue. So I go from here, I go down to this point, and then up, and this one just continues onwards. So we got an arrow for that one. All right, so you can see here that I've clearly shown the important aspects to the graphs. Again, the key ones here at this point here is key. This open circle here is key. The ones in the middle there are not. Once I draw the line, that includes all those points, so it's not as bad. You don't have to go crazy with those, but I want to clearly define the endpoints and then obviously the arrows that go along. All right, so hopefully that wasn't too bad. And then the last thing I want you to see is just, if they give you a piecewise function, something crazy or doesn't matter how obscure it is, they could ask you to do some type of transformation based on that. And everything applies the same throughout the entire function. So in this one, they give you the graph below, they say is f of x. So on the same set of axes graph, f of x plus 2 and describe the transformation. So again, this one here is representing a horizontal shift, right? In this case. So I've got here, let's do this one here, right? So we got a, let's do it in a different color here. Horizontal shift. In this case, we're going left 2, right? So if that's happening, so that means everything in here has been shifted 2 to the left. So every point that you have, so I'm gonna, since this is blue, let's say I got a point here, I've got a solid point there. Anywhere I can get nice, clear, defined points. Again, I could do this to any one of them, but as long as I have these main ones, everybody else will kind of follow. So I'm going 2 to the left. So if I go 2 points to the left, this is now going to become here. And then if I shift this one over 2, I get here. This one over 2 is here, then here, then here. So basically, I'm just going to draw now. I took each point and I shifted it, right, this amount, which allowed me, right, that allows me now to take my straight edge. I'll do this one here, and let me see if I can get another one. Since we already have green points there. Let's see, I did pink, right? So connect all of them now. And the graph should not change how it looks, right? Because it's just a transformation, which has been a translation. There is no dilation occurring, so that's all that happened is I just literally slid the entire function over, and that's it. So the key for these parts, if they do ask you to do something, is the description portion, because that's, there's not a lot of work here. So here, f of x plus 2 is a translation of f of x by a horizontal shift of left 2 units. Since it's a translation, the figure, or I should say the graph doesn't change. It just slides over 2 units to the left. That's kind of like, this portion here is kind of like your, just a description as to what's happening. But that first part is like the, the solid mathematical statement, and then this is just kind of like a follow-up describing that process. All right. So take an opportunity, go back over the video if you need to look at any of the parts, and then utilize practice problems for better understanding.